All right, let's get started. My name is Rich Crane. I am founder and chief architect, or chief technology officer of Mill5. I apologize, I used to have the chief architect title. I gave that to my partner, James. He's now chief architect. So, formed Mill5 about 7 years ago. Okay, just 2 seconds here. Founded in 2015, we're over 100 employees. We are a global technology company, global, right? Not just local here in Boston. Our core services, software consulting, performance engineering, and managed services. I'll plug this in. We do focus on a variety of different industries, but the three predominant ones are financial services and healthcare. And then we lump the next two together. This is energy, utilities, and manufacturing. They seem to have all the other problems. I mentioned these things because we do other industries. People always ask us, what industries do you do? We're very generic. We've seen so many problems given the talent that we have at Mill5 that it's hard for us to be able to say that we can't work in a different industry. But we do work in most of these industries actually right now. We have offices in 4 locations: Boston, Columbia. Actually, the funny story here is we have 2 offices in Colombia, one in Bogota and one in Medellin. Medellin is where we started. You know you're doing something good when your COO in Latin America, Geraldine, she's kind of awesome. She says, "Oh, we opened up an office in Bogota." And I said, "What?" So yeah, that was kind of funny. This is a little bit about me. Here's where I'm at socially. I'm an author. I'm former Microsoft. I'm a SQL certified master. I wrote a book on WCF. Don't ask me anything about it. And this to this day is a very cool article if you want to read about how to write high quality code in .NET. So these are just some of the customers we've done work for. You may have seen, in fact, many of you might be at some of these companies right now, right? So we've done work for all these companies. All right, so today's talk is kind of a lessons learned. One of the things we're very good at is microservices. Microservices for us is an evolution of a long-standing practice of building services over the last couple of decades. What you're seeing is this shift. It's been going on for a couple of years. You have these big monolith applications with functionality built inside. It's hard to maintain those things. It's hard to update them. It's hard to scale when you have development teams that are all trying to do work in those applications. So a microservice is a service which is independent of other services. Think of it as isolated functionality from your app. It's deployed, managed, and scaled independently. You might find that some of your services, they might have different tolerances for high availability, different tolerances for disaster recovery, different tolerances for scale. We do a lot of very high scale stuff. One of our customers, I won't say who, but they're a big online retailer. They have 130 million products online. And we had to do some really cool microservices for both cost subsidies and for target pricing. Cost subsidies is discounts, right, that you apply to the catalog. Originally they said 10% of the catalog. Well, they came back later, and we'll talk about this at lunchtime. They came back later and said, we need it across all the catalog, right? So they went from 13 million products to 130 million products. And they said, and we can't suffer any worse performance. Okay, so how do you do that? Well, microservice, right? Reasons to move to microservice-based architecture, right? So breaking apart your monolithic applications. A lot of times these things are isolated to teams or division of work, but sometimes they're isolated to feature function, right? So scaling independently. managing things independently. A lot of times it's performance-based, and we'll get into the performance-based stuff because as soon as you break apart a monolithic application, you start deploying services to other tiers. How do you think your performance will do? Anybody want to guess? Sorry, what?
Lesser performance.
Lesser performance. It gets worse.
Yeah.
A lot worse. Right? And part of what we do is tell you how to reclaim that performance. Okay? So it does get worse, and I'm going to highlight something here. If you're in process, think you're doing, say, 10,000. You go cross process, divide that by 10. So you do 1,000. You go cross network, divide that by 10 again. Right? Orders of magnitude less performance the farther away you go. Okay? Why should I learn about microservices? Well, here are a whole bunch of companies that do microservices today. Google, Microsoft, Amazon, Meta, Wayfair, Walmart, Fidelity, Apple. Anybody work for any of these companies? I've done work for 1, 2, 3, 4, 5, 6 of those companies up there, right? The idea here is these companies have extreme scale, right? They need extreme scale scenarios, and a lot of times they'll use the microservices architecture by default. So I mentioned some of these things already, but we'll go over them one more time. No longer a monolith, one big happy application, right? So the functionality that you were using in process is no longer in process, it's somewhere else. In fact, I'm going to highlight something from my last talk. A couple weeks ago, we were building a small little mobile application called What Are the Odds? It's a lottery-based application. When we first started developing, we mocked out our services. Okay, so we didn't have our backend services up and running, so we mocked them out so that we can get the UI development going. And funny thing is, 1 or 2 of my developers were assuming that those services were in memory, and it worked fine. But then we took that service and we put it on another box in Azure. It was an Azure function at that point. And they were like, why is it not working? Right? And I said to them, did you consider the performance aspects of this? And they're like, no. So traversing those network boundaries is non-trivial. The other thing too is application behavior. So when you move to other tiers, you have to consider transactional boundaries. I mean, just because you did something in process does not mean you're going to be able to do so cross-network in an efficient manner. I had one customer, their application was deployed on a single machine. It was a web app. The database was on that same machine, right? So they moved the database. Do you think the transactional, nature of their app was good? No. They were using LTM, Lightweight Transaction Manager, in .NET, right? They were using it kind of wrong, right? Let me ask you something. So the Lightweight Transaction Manager in .NET supports distributed transactions. It also supports database transactions. Depending on what you do, you might be doing it wrong. If you have a single transactional resource like a database, do you need distributed transactions? The answer is no, right? The whole purpose of distributed transactions is to coordinate 1 or more transactional resources. Well, guess what? As soon as you start remoting things behind a service, and those things are remoted someplace else, things behave a little different. Then there's a question of eventual consistency versus being always consistent. When you start remoting things, you start to think, is being always consistent a good thing? Can I trade off things like always consistent for eventual consistency and still maintain the same functionality? So these are all the things that we think of I did want to highlight some of the service technologies I've used throughout the years. In the mid-90s, I was working with Corba and message-based service technology. Then became late 1990s. Good friend of mine, Dave, was in the last talk. I think he's speaking right now. He and I would always talk about COM Plus, and Microsoft Transaction Server. Interestingly enough, when I was at Microsoft, my business partner, Shri, was working at State Street. He brought in a COM Plus application, and all the same principles that are in this slide deck, I used with that application. We got 20,000% performance improvement. I'll say that again, 20,000% performance improvement. Now, he keeps telling me, he's like, it wasn't that much. And I'm like, yeah, it was. So, enter .NET Remoting. Okay, .NET Remoting was very cool. I've worked with a lot of customers on that. And then early to mid 2000s, kind of when .NET came out, we had what they referred to as WSI Basic Profile Web Services. This is your traditional SOAP services. I call this the HST, hook stuff together. So it's HTTP, it's XML, go. Right? And this was great for cross-platform type stuff. Then came WCF. I know a little bit about WCF. I try not to think about WCF these days, although we still have customers that do WCF, including the new WCF, like .NET Core type stuff. But I wrote a book on it. It was well received. To this day, you know, WCF, I think there's a lot of cool stuff. I think the challenge with WCF is too many knobs, right? Too many dials. And, you know, people get lost in that. Then enter the browser, right? So the browser came out. Browser's ubiquitous. It's on every platform. It's on mobile devices. It's on Windows, Mac, you know, you name it. And came RESTful services, right? This is the standard HTTP transport. But then we looked at things like JSON. Well, JSON is not as verbose as, say, XML. Now, if you look at REST and the work that platform companies like Microsoft, Amazon, Google, they said, how can we get better? And Google came out with gRPC. So gRPC was an evolution of building service technologies at Google. And they came out with this, and it's been adopted by most of the platform companies, including Microsoft. And it does provide extreme scale. I will highlight something. In my real world performance testing, if you do all the best practices for building RESTful services, you can get to almost the same scale as a traditional gRPC service, okay? It's pretty amazing. Do I expect gRPC to evolve and get even better? Yes, right? So, and then there's some new stuff, right? So RESTful services, gRPC services with HTTP3. How many people have looked at HTTP3? How many people truly understand the differences between HTTP1, HTTP11, HTTP2, and HTTP3? Okay. We'll talk about some of that, right? We won't get into all the things, but we'll get into some of the things. So.
What does MS Graph fit in there?
Like GraphQL?
Yeah.
So,
do you use it or?
I do use it. We do a lot of work for an online retailer. You could probably guess who it is. I'm not going to say, but we do a lot of GraphQL for them. Okay. GraphQL versus REST is kind of an interesting little problem. I mean, OData is another version of kind of like a query language over HTTP. So when I look at GraphQL, OData, and REST and gRPC, I will typically stick with REST for the most part. It's simple, it's easy, it's ubiquitous across all platforms. The libraries for some of these things, GraphQL is probably the more adopted one. That's a different variant. It's still HTTP, but you have to have client-side libraries to really use it well. It's not to say you can't use it if you don't have a client-side library, but I don't want to handcraft my own queries and things like that. So, but we do use it. You know, but many of the same practices here. So for example, we were doing a GraphQL, and because the transport was HTTP, I was like, why is HTTP compression not turned on? Right? You query, you get a response back. I want that response to be compressed. I don't want a large document coming back. But people, you know, it's interesting. I've queried the internet and found that a lot of best practices I talk about in this slide deck aren't being talked about on the internet. Why is that? I don't know. And you know what? I told you earlier that we had one customer, I'm going to talk about it at lunch, you know, because of Putin and his little war that he wants to go do, this customer was in a bad scenario. We had a microservice out there that was developed, that was doing some things, and we had to go from certain volume of calls to 10 times that volume. We're not talking a few calls. We're talking like 130 million calls, okay? When you want that level of stream scale, you have to do the stuff in here. And I don't see people talking about that. In fact, I would say at that particular place, they don't even talk about half these things, okay? So GraphQL is good, but you're gonna benefit from that in here. I don't call it, I think I might call it out, but I don't call out GraphQL. So this one should be familiar to everybody. If it's not, you are now aware of it. The first lesson learned is to be chunky, not chatty. Many years ago, this is about 2001 timeframe, a good friend of mine, Steve Tarmy, he is now my top architect at Mill5. He came into Microsoft with a customer. The customer was a big security company. They handled badge and door access for a lot of high security buildings. You might know one of the buildings, just happens to reside at 1600 Pennsylvania Avenue. Right? But they had a stream scale problem, or actually, I shouldn't say that. They did have a scale problem, but they had more of a performance problem. They were doing calls into remote objects, very much like .NET remoting, right? Remote objects that would live on the server, and they would call properties, and they would call methods on those objects. And it ended up being a very chatty app, okay? And that very chatty app did not perform, okay? And we switched them, right? There was a guidance from Microsoft at the time, online on MSDN, to say, be chunky, not chatty. And so we looked at their usage patterns. We said, hey, you're making calls into this one object 10, 20 times. Can we make one call, right? Can we batch up these things and just do it once? Well, this is very much like a, where you see this chunky versus not chatty is in the object-based middleware. A lot of times, you know, that used to happen all the time, but people still do this. You know, I have something on the server and I have cached in memory and I'm making multiple calls into it. Don't do that. Every time you traverse the wire, you pay that penalty. You had said it earlier. I traverse the wire, I pay a performance penalty. And it's not small. It's multiple orders of magnitude. So the idea here is to minimize the number of calls across the network to complete an operation. You start to do this, you're going to reclaim performance. Now, I'm not saying take all your calls and roll it into one. Divide it up by functionality. You could still make multiple calls, all right? But there are other types of optimizations that you can do, and you'll hear some of them throughout my talks of the day. Okay, minimize the size of your payload. All right, so let's talk about XML, text, and binary. So how many people think that, or JSON even, right? How many people think JSON is the most efficient serialization format for sending bytes across the wire?
Versus what?
Versus, say, well, actually, let's do that. JSON versus XML, who wins? JSON. All right? JSON versus binary, who wins?
Binary.
You need binary, right? Actually, this is kind of a one. JSON versus text. JSON is text, right? It's a trick question, right? So, I mean, there's many different serialization formats. They all have their benefits, yes?
Well, but like in HL7 where it's pipe delimited and you don't have the expense of tags.
Or even CSV, right? You know, yeah, I mean, there are all types of serialization formats. But then the question becomes,
Now you have to know the format.
you have to know the format, and which ones, I'm gonna use the words, are ubiquitous, right? So if I were to say, I'm gonna use SOAP, okay? SOAP is an XML, variant of XML, specifically with, you know, traditional web services, the ASMX, the WSI Basic Profile Web Services. How many platforms support that? Which ones?
A number of them.
A number of them, right? But are there people using them today? Or is there really a lot of investment in that anymore? No. How many platforms support JSON? Every single one, right? Every single one, okay? How many people support binary for Windows? Windows. You know? So, you know, I have to go back and look and see, because now that WCF Core is kind of cross-platform, I'm curious if they allow for that. But my team, I have a few guys that do that, and so I would ask them. But you know, the key here is knowing your serialization format is a big thing. We'll talk about that a little bit more. But even in this case, right, what we're trying to talk about is minimize the size of your payloads. Everybody familiar with a GUID? Okay. How big is a GUID?
16 bytes.
How many?
16.
16 bytes. How big is it textually?
About 33.
32. Right? Is there alternative formats of a GUID?
Yes.
Right? Do you know how many?
Yes.
What?
Base 64 encoded.
Yep, base 64 encoded. Basically small GUID.
So it says about
10 bytes.
10 bytes.
Yeah, about 10 bytes. So that's an example of minimizing the size of your payload. Okay? Obviously, if we were binary, it's 16 bytes. If it's text, the default would be 32. Could we implement something to get it down? Here's the other thing. JSON. When you look at the JSON format, you have a property on your JSON object and the value. Well, if I said the property is first name and the value is my name, do I have to send first name? Well, you have to send it, but do I have to call it first name? Right? Can I call it FN? First name. Right? So here's another thing. If I reduce all the bytes and get to, say, binary, right? And it's very unique data, do you think that might be highly compressible?
Possible, yeah.
Possible, but maybe the compression is not as good as, say, if it was text. Is text highly compressible?
Yes.
Do you think JSON's highly compressible?
Absolutely.
Absolutely. So when you look at this, you say, oh my, right? The default, right, by the way, the default is this is turned off, this compression. The default for byte shaving and things like that, you have to do these things. If you don't do these things, you're not going to minimize the size of your payload. Now, do you think user experience is a good thing? Do you think if you're downloading big things off of services will lend itself to a performant UI? All right. Byte shaving. All right. So I mentioned a couple of these things. The first one is modify your contract. You know, this is an example here where we're taking the JSON property name, and I gave a couple examples where it's like, hey, here's your values, right, of sample data. Here's your values of the property name with the type. Well, rather than using the default, and the default is actually the name that you give your object, right, and its property, right? So if I didn't have this JSON property, sample type would come down. Right? Well, if I change that, I save 8 bytes. Okay? I mentioned the short GUID. Actually, standard textual representation is 36 bytes. My apologies. Not 32. 36 bytes. So I have a custom JSON converter. Right? Change from GUID to short GUID. Use the short GUID, 14 bytes. Instead of, or 14 bytes saved, I should say. So it goes down to 22. Right? This is a good example of byte shaving. Now, a lot of times, you have collections of things off of JSON, right? You know, you say, hey, I want a collection of, I mean, the last talk I was talking about a little app, we have a collection of lottery results, right? So the latest lottery results, I have Mega Millions and Powerball, so there's only 2 things in there. But it's still a collection, it's 2 items, so it adds up. What if I had a history of lottery results going back 30 days? That's more, right? So realize that this pays off very quickly depending on what you're doing. Compression. So Microsoft ASP.NET Core response compression. There are 2 things about this that are kind of interesting. Number one, I don't know why, but I've been saying the last couple of years that most developers are forgetting or not knowing anything about this. I just got done an engagement with a very big customer. They didn't have this anywhere in any of their .NET service code. And they were sending tons of bytes off the wire. I remember doing an engagement for Reuters.com, right? So Reuters has some of the biggest news on their website all the time. I was able to implement a compression technique on their website that not only saved them 50% of their traffic, but at no additional resource expense. Meaning no more CPU, no more, in fact, I think it was less memory. The reason why I say that is because there was so much CPU being eaten up, sending bytes on the wire, that we reclaimed that CPU and put it towards the compression. Okay? Reuters came into Microsoft when I was working there, and they were funny. They were like, we're not going to learn anything from you, Microsoft. We know it all, everything else. We've been to every lab out there at Microsoft. You know, you can't teach us anything about performance of our online site. 2 weeks later, they sent a letter to one of the top VPs. Who is this guy, Rich Kramer? Right? You know, he just saved us 50% of our traffic on one of the biggest websites out there. And so please, you want to do some big things, turn this on. I wish it was turned on by default, to be honest. But part of the reason why I think they don't turn it on by default is because they want you to see the performance issues, right, and have you correct it. This is sort of a Band-Aid.
If you have a browser app, is it easy to compress it?
Yeah, so but this is browser apps instinctively handle this. So you have to have the accept encoding header, right? Tell it I support JSON or compressed responses. And browsers typically send those things. In fact, let me go back to the last slide. There is something I do want to mention. What's the default compression algorithm for HTTP compression? Anybody want to guess? Which one?
Bumble zone, isn't it?
It's gzone, right? Which I'm sure is some variant of that. Google came out with Brotli. Brotli's pretty cool, right? So mess around. Deflate is an older one. I don't see anybody using it. They just add it just in case somebody decides to call you with it. But this is how you add these type of things. See here I have gzip and Brotli. So I turn both of those on. And you know, Brotli's really, really, really good compression. By the way, so you know, you can do this both with REST, which is what you're seeing here, and gRPC. Nice thing about gRPC, which I'll probably talk about later, is you can do bidirectional very easily, right? Bidirectional compression. So if you're sending stuff up, you can compress it. We've done that with a large customer. who is in the IoT manufacturing space, they have devices that are sending data to the cloud, and we want to compress on the way up, right? Now, you can get compression on the way up with your HTTP communication. You're never going to find an article on the internet until I write it. But it is possible.
So do you have to decompress on the receiving side, or?
No, well, you do,
Okay,
but that's handled by the infrastructure for you.
okay.
So typically, you'll have your HTTP client,
Yep.
and you just make sure that HTTP compliant says use compression. Okay. All right. Let me see this one. Okay, byte serialization. Everybody's probably familiar with Newtonsoft, yes? Everybody familiar with Newtonsoft? Okay. Well, James, Newtonsoft King, where does he work now? Microsoft. What do you think he's working on?
System that doesn't text station.
Yes, he's also working on gRPC. Okay? So he's working on system.text.json. He's doing the next generation of stuff. So there is a lot of things. Newtonsoft JSON was some guy, I think he was from Australia or something like that, James Newtonsoft King. You know, I'm so jealous of him. He has one of the most downloaded .NET NuGet libraries on the planet. Right? In fact, I think it's probably the number one. But so he's made his mark on software forever. And I have two, but mine's not as widely known. You know, there are advances in system.text.json. If you do file new and they're still doing Newtonsoft JSON, stop doing that and move to system.text.json. There are efficiencies in moving to that serialization library. Google Protocol buffers, right? So Google Protocol buffers is another type of serialization format. It's highly efficient, okay? It is meant to be better than JSON in a lot of regards. If you could move to that, you might see benefit, okay? The challenge with something like an alternative serialization format is your reach. JSON is available in every browser, every OS, every Android device, every iOS device, every iPad, right? So it's not to say you couldn't get Google Protocol buffers there, but if you're building a web app, it's in every browser, right? You can call a service, right? You have JSON. It's not to say you couldn't do it, it's just to say it's more difficult, right? So there are many different types of JSON formats, serialization formats. JSON, Google Protocol buffers, message pack. Anybody know what BSON stands for? It's binary JSON, right? So XML and many more. So, but be careful when you pick these things. I've already mentioned it more than a couple times. Reach is probably your number one challenge there.
Hey, Rich, why would the people that have an XML format just move to a JSON format? Same so.
Yeah, you know, they should probably just move, right? I mean, I don't see any really big reason anymore. I mean, some people think that XML is a little bit more structured. It is, like, for example, you can have something like XML schema around it and do validation.
One of the reasons would be SSLT or transformations.
Yeah. Well, hopefully you're not doing SSLT transformations in the context of your app anymore. In fact, I wrote an article a long time ago. XML plus XSLT over HTTP sucks, right? It is a huge performance problem. A good friend of mine who worked with me at Microsoft, he was on the same team, and then he worked with me again at Blue Metal and Insight. He is now one of the top program managers for iOS for Apple, okay? He hated the whole XSLT thing because it was just a mission to do work and transform something. In fact, one of my mentors, same team, he said, when you deliver something to a client, you deliver it to them in the format that they expect. Okay? If you have XLT in the mix, you're transferring it to get to the format that they expect. Right? So it gets hard to cache when you do stuff like that. So, all right, batching. Batching basically says, I need to go get n things. Don't make n calls. Make one call, but send n requests. The cool part about that is if you design your services so that you actually have one call with n requests, you are doing set-based type work. And you're optimizing things across all of that. And you get more efficient in your programming. It just naturally happens. If you wanted to do one call at a time, one request at a time, guess what? A batch of one is that single request. So one thing I never do anymore is design a user interface that takes one thing. It always takes multiple requests. All right? Now, there's a few exceptions, like get my user profile. I'm not going to ask for multiple users from an app that has a single user on it. But if I said, hey, get me all the lottery requests for the last 30 days, I'm not going to ask for every day that there's a lottery. I'm going to say, give it to me for this date range, or give it to me for these dates, that type of thing.
How can that work in a fan out? If you're, say you have an Azure service that loads a file. So I give it the file, and then it calls microservices to parse that file, and it basically takes the file and goes bing, 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 bing to all these services, rather than doing it in a batch. To me, that seems a lot of overhead, rather than saying process this file all at once.
Yeah, I don't know your specific scenario, but is it a single file that you're contending on?
Well, we do it for multiple files, but
Multiple files?
yeah.
Okay,
So, we get a file in, we stage it into a database, and then we call a process to transform the data. And it literally transforms it row by row in each microservice, one row at a time, but it will fan out to maybe 1,000 or.
oh my God, I
Yeah.
wouldn't do that, right? I would look at some type of parallelism,
Yeah.
right? I think of parallelism in a couple of ways. Number one, let me give you the high performance computing route. I'm not saying HPC, I'm just saying compute parallelism, right? So if the workload that you're talking about, where you have to process each individual file, I would have a high performance compute process that.
Yeah.
Or if it's data parallel, okay? I'm not saying use this either, but I'm just giving you an example. Hadoop is very good at finding where the data lives and bringing the compute to that data to process, okay? So I'm just mentioning those two things because those are types of parallelism in compute. These services are making gazillion calls, and I've already said, as soon as you make a service call, you are multiple orders of magnitude down, right? In fact, I'll highlight big online retailer. They have 130 million products, and they have a pricing engine that runs continuously 24/7, okay? It takes 2 hours to go through their entire catalog for pricing. We had to develop a service which computed a single value on every product. That single value was an additional cost subsidy to increase the cost of shipping. Why did we do that? Thank you, Putin. Right? Your little war caused retailers to incur bad shipping costs and oil prices and fuel surcharges and things like that. Well, inside the service, we would first do batching. We would say, hey, you can make 10,000 requests in one call. Then inside that service, we would take those 10,000 requests, parallelize it. Now, our parallelism wasn't crazy. it was maybe like 8 parallel threads. And we would go through those 10,000 requests, and we would be able to return responses very quickly, okay? But here's the thing. Yes, we did parallelism, right? Yes, we did compute. We had an in-memory cache for some of that data and did a query to join the data for each one of those individual requests in the batch, okay? But did we incur, how many service calls did we do? Well, they had 130 million products, divide by 10,000, which was the batch size. That's how many requests that could be done, right? And we would scale that out across a farm of, say, 5 or 6 instances, right, in Kubernetes. But would, on our back end, we make millions of calls? Hell no. If we had to make those millions of calls, it would never work, ever. So, okay. Here's an interesting question. If I batch and turn n requests into one request of a service, so I have 10,000 requests, it's now one call to the server, I now get 10,000 responses. What did I talk about earlier? Compression, right? If I have one thing and I'm compressing it versus 10,000 things and compressing it, I'm going to win every time with that compression, right? And they're all like things, which is even better. Because they're like things, it's going to compress them more, right? So batching and compression work extremely well. And yes, you can do both requests and responses, but requests are initial. Yes?
With the microservices architecture, right, how would this batching work, right? Even though you send it like a one request, it still goes to like each and every microservice, right?
No. I'm talking same request to a single microservice.
Got it.
I'm not talking spanning across microservices. I'm talking if you have the need to call a single microservice, making multiple requests into that single microservice. JSON. How many people are familiar with the doubling algorithm with data structures in .NET like lists? All right, I'm familiar, you're familiar? Okay, so what's the default capacity of a list in .NET? Anybody want to know? How many items is it sized for? I think they changed it recently.
32?
No, it's much lower than that. It's like 4 or 8. I think they changed it to 4. So what that means is anytime I go to add to the list checks to say, hey, I can have 4 items in the list. Well, when it starts out, I can have 4 items, but I don't have 4 items. I have 0. And as I add, it takes up a space in the list. Right? So add takes a spot number 1. Add again, space takes a spot number 2. Until it gets to 4. When it gets to 4, it adds it, and it says, okay, my list is full. Well, the reason why is it's backed by an array. That array can't be resized, right? When you take and need to resize an array, you create a new array, and you copy all the references to what's in the array or the values into the new array. How do you think that does on garbage collection and memory allocations? Not good. Well, the way they try to get around it is a doubling algorithm. So they want to minimize memory allocations. Well, if they minimize memory allocations, they'll say, oh, we're going to double the size of the array because we know you're adding. So if I had 4, they'll increase the size to 8. So when it hits 8, they'll grow it to 16. When they get to 16, they'll grow it to 32. The reason is they're not increasing the size of the array for everything that you're adding. They're trying to minimize the allocations. Here's an interesting question. Can you pre-allocate the size of the list and say, I'm about to add 10,000 things?
Yes.
Yes. How do I do that with JSON?
I guess you could count how many items are on. I mean, it is just bytes. You can scan ahead if you could do that.
But you can't, right? The JSON serializer is kind of dumb and stupid, right? It just says, I have an array of things, and it does exactly what I just said. Let me start adding. I see something more. Let me start adding. And it goes through all those doubling algorithms. So Years ago, I built a competitor to Instagram. It was fun, right? I wish it was still around. They called me one day and they said, we want you to be the CTO, right? We'll give you 51% of the company. And I said, no. The reason why I said no is because the investors fought amongst themselves all the time. And I know technically I could win, but there's another business side of the component and they weren't the people to take it to fruition. But we kicked butt. We really did. We were fast, right? We could support an entire event, right? Like a concert, and you taking photos at a concert, and if you wanted to see, say, Elton John on stage, and there was somebody in the front row, but you were in the, seats all the way in the back, you can get that photo from them instantaneously, right? It was very cool. It was kind of awesome. Number one performance issue, this. This was our number one performance issue. I was shocked when I saw that. You know what we did? Every time we had a collection, we emitted custom JSON that basically said the number of elements or number of items in the thing. So our custom JSON serializer would say, hey, we see a collection of things, but we have the number before we start reading the collection, and we can then pre-allocate the list. Eliminated all our allocations. Now, in system.text.json, they're not doing that particular optimization, but they're doing a ton of memory optimizations that do help with that scenario. But they don't do that one optimization. So, watch your memory allocations. Yes, sir?
But how do you actually tell the underlying array how big to be?
Custom converter. Right? So when we, on the server side, we know we're about to emit a collection of saying 1,000 things.
Right.
We have a custom converter that will emit JSON, which has a property prior to the collection that says, hey, it's a hint that helps us allocate the size of the array. On the client side, we have that same custom converter, so one's writing, the server side's writing, the client side is reading. Client side reads, oh, wait a second, I'm about to hit a collection that's of size, say, 1,000.
And you tell the list to be 1,000.
And I tell the list to be 1,000, and we're good to go.
So are you just adding like an extra property?
Yep. Using all the techniques I said before, right? The little property has a name that's really small, that type of thing. Persistent connections. This one's fun. This goes in, starts getting into the different HTTP standards. So in HTTP 1.0, there was no concept of persistent connections. What this is in HTTP 1.0, when an HTTP request is being made, you made a connection, you sent your request, you got your response, and then what do you think it did right away? Close the connection, right? Enter HTTP 1.1 with a little thing called keepalize, which is basically persistent connections these days. Now, you open a connection, you make a request, get a response. That connection is pulled, okay? You go to make a request again, you don't have that overhead of opening and closing the connection, right? It gets that connection from a pull. There is no magic implementation here. This is a standard. Standard says, hey, what's the default number of connections that you, as an HTTP client, should have? Anybody want to know what the default value is according to the standard? 2. Right? Guess what .NET did? They said, I'm going to listen to the standard. Guess what Google did? They said, I'm not going to listen to the standard. I want things to be fast. I don't want to do that. Right? So even in the browsers, right? So this came up because of browsers. Browsers make HTTP connections. And what happens when you render a HTML page, you have multiple things that the browser is trying to go fetch. It's trying to fetch JSON files, it's trying to fetch JavaScript files, it's trying to fetch images, it's trying to fetch all these things. What it doesn't want to do is overload a server and say, I'm going to create tons of connections. But it wants to create enough connections to have things look responsive. So while this HTML is coming down, it can start rendering an image. while this HTML is coming down, you can start getting the JSON file, those type of things. Do you think this is good in server-to-server communication? Think about it.
I've had to deal with this. I mean, it's not, but
Yeah.
the strategies there can be challenging.
Yeah, well, let me put it this way. A lot of times, if you have from one server calling to a back-end server, you have a bunch of users on the front end or a bunch of things calling that front-end service, and then you're multiplying, right? You have this fan out, right? And you're sitting back and you're saying, hey, I need to call all these services. Well, let's say those services are behind a load balancer, right? And so you have one URL, right, that you're hitting. This is host-based, URL-based. Do you think if I have to call 10 things and the default connection limit was set to 2, what do you think would happen? When it got to 3, it would block, right? And wait for the 2 requests to get done, and then serve up the third one. Now, in ASP.NET, they realized this, and when you host ASP.NET service, they increase the limit from 2 to like 10, right? But is 10 a good number? I don't know, right? What are you doing, right? So in this case, they have something called the service point manager default connection limit. I always do this. My team always does this. In our static constructor of our HTTP clients, whether they're server side or client side, we will always increase the limit. The question is, what do we increase it to? Server side, this is a great example. We always say something like 200. And what we do is we do math.max on this, right? We'll say, hey, we'll take the existing default connection limit, comma 200, and whichever is higher is what we'll use. Why? Because we might have multiple services on the same server. Some might want a max of 10, some might want a max of more, right? This is a global setting. Can you get very specific on a host? Yeah, but we never do that, right? We just say, all right, this is good enough, and that's what we set. So the idea here is don't limit yourselves arbitrarily. Okay. How many people are familiar with the HTTP client? How many people reuse the HTTP client? How many people dispose of the HTTP client? All right? So,
If you use the right interface, you can.
yeah, okay. So the idea behind this, this is all a lot of low-level networking stuff. If you go to this reference, and I'll make the slides available, if you go to that reference, you'll see that creating a new HTTP client, getting a new connection, there is inefficiencies with not just connection overhead, but just inefficiencies in using the HTTP client itself, okay? Reusing the HTTP client, you get significant performance improvements, okay? And especially on server resources, right? So this will help with the server resources too. So the idea here is you often use a singleton, some form of static, and you're reusing that client. All right, so this is a cool thing. This one's pretty cool. We actually did this. I'll talk about this a little bit more at lunch. But anybody familiar with Bloom filter? Anybody familiar with dictionaries?
Cooper filters that, but.
Okay. So, all right. So the idea here, we had a customer, that same $130 million product customer. When they wanted to give discounts on products for things like shipping, their intent was to capture market share or to, sell more products, those type of things. And they would do so on 10% of their catalog, which meant 90% of the time when they would call the microservice, there was no discount. So, my question to you is we would make well over 100 million calls to get nothing. How can we handle that? Okay, enter Bloom filter. Bloom filter basically says, should I make a service call? It is a probabilistic data structure that is very small. Its role is to say, is something available? No or maybe. Not yes or no. No or maybe. A dictionary basically says, does something exist in the dictionary or no? So you know exactly what's in that dictionary. But in order to know what's exactly in that dictionary, you need the whole dictionary. Right? If you have 130 million items, that's a problem. Right? If you have a probabilistic small data structure, I mean small, right? For 130 million products, it's only like a megatic, right? And it doesn't change. It changes, but it didn't change so often that we couldn't cache that client side. So what our client does is it says it has a Bloom filter, which is the known set of things in the dictionary cached on the server. And it says, hey, I want to know the cost subsidy discount for this product. And if the answer is no, it does not make the service call. If the answer is maybe, it has to make the service call. But if I can eliminate the majority of the 90% of calls that I would have made, it's a huge win. Huge. Google does this a lot on their back-end services. A lot. Okay? Now, the funny thing here is, enter Putin, and enter the, cost subsidies are a positive thing, it's a discount. Negative cost subsidy is an increase in the price. When Putin did his little war, I don't even call it a little war, his war, because it's not a trivial thing, but he increased the shipping costs for every online retailer, period. And the challenge with that is we had to go from 10% of the catalog to 100%, because we had to return negative cost subsidies at that point. But all the tricks that you've heard me talk about previously were what we used to get to that point, right? 130 million. Protocols. Okay. There are tons of protocols out there, all right? Everything from HTTP 2 and 3, MQTT, UDP, TCP, WebSockets. How many people have heard of WebSockets? How many people use WebSockets? Okay. How many people do TCP? How many people have heard of HTTP 3? Okay. How about MQTT? Anybody hear about that one?
I've heard of it.
Where is MQTT used mostly? What did you say? IoT devices, okay? And also satellite type stuff, right? IoT devices, satellite. UDP, where is that used? Yes, sir.
Any time that you can lose data in the phone.
Yeah. Yep. UDP, where do you see that a lot? Games. Gaming, right? Right? So the challenge with protocols, these protocols allow for different types of efficiency. Like WebSockets. WebSockets sheds the HTTP nature. HTTP is built on top of TCP. If you negotiate a WebSocket, it sheds that HTTP, drops down to TCP, and you shed that overhead. Overhead of the protocol. TCP, you're just saying, I don't want the baggage of HTTP. HTTP3, Google has done some amazing things. It's now part of the standard. It's now being baked into .NET. It's in .NET 7. You see a lot more in .NET 8. Initially, some of the challenges were, did it work on Mac? Did it work on Windows? I think they've been resolving some of that. MQTT, I still only see that mostly in IoT devices. It's a pretty common thing. I love UDP, but I don't do a lot of gaming these days, although we'll see. Maybe I'll come up with that one app that I spoke about earlier. We'll figure out a Bluetooth mechanism and do UDP or something like that.
The other place you can see it is in video.
Where?
Video.
Yeah, oh yes, you're absolutely right. So, Interestingly enough, Microsoft is working on their gRPC stack and trying to abstract away, some of the protocols with gRPC so that you can actually change the protocol. So if you need better performance and you don't need the reach, maybe you can use some of these protocols. This is just a little bit information on HTTP3. The leadership and technical leadership at Mill5. We talk about HTTP3 a lot. It's going to be a big game changer on the internet. It really is. I mean, the efficiencies associated with it are awesome. The challenge becomes just adoption of it in devices and firewalls and proxies and all sorts of stuff, right? But the idea here is it adds certain features, like the quick stuff is UDP based, okay? HTTP2 brought multiplexing, okay? So these things start to add benefit. Could you do, some of this stuff kind of ad hoc? Yeah, but not as good as if it's baked into the protocol. So you're going to start to see this. We always enable all HTTP because you can actually enable all your services, HTTP2 and 3 simultaneously, so we enable both. API gateways. I threw this one in here because of probably some of the reasons that you were mentioning earlier, is when you build these microservice architectures, what you're going to start to find is that you build these individual things out, and then you want to create new services. And those new services are an aggregate of multiple services, okay? Maybe you might want to do some other stuff, right? Like TLS, SSL offloading, right? So there's an overhead with encryption. If every one of your services has to do that, that is an overhead. Maybe you shed the encryption layer at the front, and then you just start talking HTTP once you've gotten past that front. Load balancing. Well, you need to scale. Your services can only scale a certain amount. You want more performance. Load balance is the key one. I'm going to say caution this one. Years ago, when I was at a .com back in 2001, we had a load balancing of services. Yes, 2000, 2001, we were doing HTTP-based services. I'm shocked at that. Was it ASMEX services? No. It was actually built on classic ASP, believe it or not. But we had an F5 load balancer that would say, hey, route to a server in our farm based on response time. So the lowest response time server would get the next request. Guess what responds very fast? Errors. There was no concept of detecting the error. And one server would start throwing errors, and we had 15 servers. So all traffic went from 15 servers to the one server that was sorting errors. So I just throw that because it's a funny little story, but load balancing is better these days, right? You check the HTTP responses, you look for errors. There are other types of resource algorithms like round robin or resource-based, not just response time. Security risks, DDoS. I'm sure you're going to hear from Patrick talking about some of this stuff, but having something in front of you to handle some of these things so that every one of your services doesn't. We actually have a middleware layer that handles that some of that stuff because sometimes some of these products can get expensive and we want some of this mitigation. So we'll do things like IP rate limiting within our service. But could the gateway do it? Absolutely, right? Caching. Maybe you have a service that doesn't support caching today, but you know you can cache it, okay? This is where an API gateway comes in, all these different things, right? So these are augmenting features on top of already existing services. Could you build these things into services? Absolutely. Can you make this separate from your service so you can just focus on the functionality of your service? Yes. Okay, remember when I said part of microservices is scaling functionality independently? Maybe this is infrastructure functionality that you can scale with your API gateway. We use Kong a lot with our customers, so everybody knows. I'm not going to call it regret because it is something I wish I had the opportunity to do. Back in 2008, when I was working at Microsoft, anybody remember what happened in 2008? It was like the big mortgage crisis, right? And I had a job offer to move from the MTC to go work for Steven on the .NET team, okay? He's still a good friend. I talk to him, probably once or twice a year. But the idea is, he has a great blog that talks about performance improvements. So if you're on .NET Core or .NET 5 or .NET 6, move, right? Just upgrading is a simple thing to do, right? There are key performance increases in all these areas in .NET 7. Compression, JSON, networking, collections, all those things have upgrades. Didn't I talk about most everything on that list already in the slide deck? Okay. That's how wide the .NET 7 performance improvements are. And I will say to you, you will get a significant performance increase by moving forward. So with that, here's some additional references. I've done some work on gRPC performance. So you can go out there, look at GitHub. There's a repo under Mil5 that shows a lot of ways to use REST and gRPC and talks about the different performance aspects. Some other links for your reference. So with that, that's the end of my talk. I'll throw it out to everybody here for questions.